Java comes with a bunch of classes that support graphics, and we'll use a bunch of these later in the semester. But for now, in the next few sections, we're going to use one called Turtle Graphics. This is non-standard. It's special to what we're doing, and it's going to help us illustrate some of the big ideas of object-oriented programming, particularly inheritance and polymorphism. I'll post the raw source code for Turtle Graphics up on the site, but for now, that won't be our main concern. This graphics package was originally developed at MIT in the late 60s in a different language called Logo. It's a language for little kids. And if you want to understand how it works, the way you think about it is you imagine a turtle. Now, this turtle has a pen attached to its tail, and it's crawling on a piece of paper. As the turtle moves, it marks up the piece of paper and ultimately leaves drawings on the screen. We can give the turtle different commands to tell it how to move across the paper, to tell it to turn, to tell it to step, to change the way the pen works, all that kind of stuff. And this way we can essentially program the turtle to do different things, to draw different pictures, however simple or complex. Now that turtle is an object, okay, and that's how we're going to work with it. And if you think, this is really similar to what you might have seen in Scratch or Snap if you've ever worked in either of those two visual programming languages. Now we actually won't think in terms of the turtle itself. We'll just focus on the pen tied to its tail. And that pen is an instance of the class standard pen. Okay, later we'll encounter some other types of pens, but for now this is the one we'll work with. And we draw in a window, and we command a pen by calling methods that belong to the standard pen class. Here you can see a bunch of them. There's the home method, which takes us back to the center of the screen. Set direction, we can set it to a cardinal direction, anywhere from 0 to 360 degrees. We can also give it negative direction changes. We can turn it by some number of degrees. We can bring the pen up or down so it doesn't draw or does draw. We can move it a certain number of steps, and we can set its color. Initially, for us, when we create a new pen, that pen will be in the center of the graphics window at 0, 0 if we're working with a normal Cartesian coordinate system. It's going to be down, in other words, writing, and it's going to point north. That means if we move it, the pen will, by default, move north until and unless we change its direction. So here's some code that draws a square 50 pixels by 50 pixels in the center of a graphics window. You can see we instantiate a new pen object, standard pen equals new standard pen. We lift the pen up, we move it up by 25 steps, we turn it by 90 degrees, we move it 25 more steps, and we set it down, and now we're in the top left corner, ready to move, ready to draw, and we draw the square. Turn it 90 degrees, move it 50, turn, move 50, turn, move 50, turn, move 50, and we're back to where we started. If you open up the code examples and actually run it, this is example 0501 class draw a square. If we run it, you can see that it does exactly as we expect. It draws a square in the middle of a graphics window. Now, the way our window is defined, if we resize the window, the square is automatically redrawn so that it's still in the center of the window without rerunning the program. And of course, we can close it just as we normally would. Next thing you want to do before you move on is actually install the Turtle Graphics package by adding the .jar, the jar file, to your build path. That's a Java archive file. I'll post separate instructions on the website for how to do that. It's quick and easy, and it's a great way for you to get this code so that you can make your own Turtle Graphics images.